Awesome. So hi, I'm Casey Canfield, and I am leading a project that's a partnership between Missouri S&T, St. Louis University, UNOS, the United Network for Organ Sharing, and then we have funding from the National Science Foundation, and we're developing AI tools in the transplant space. And so we're really focused on addressing challenges related to meeting the high demand for kidney transplants. So I'm going to talk a little bit more about myself and kind of how we got into this work, as well as the actual work that we're doing. So first, I'll introduce myself. So I got my bachelor's in engineering systems at Olin College of Engineering, right outside of Boston in Needham, Massachusetts. I was really involved in human-powered vehicles. I remember competing against S&T and S&T being the team to beat back then. I assume it's still true. I haven't checked. I then went on to get my PhD in engineering and public policy at Carnegie Mellon University in Pittsburgh, Pennsylvania. And a big part of this program is taking people who have a background in engineering and learning how to think about public policy problems where you can't ignore the technical constraints. So thinking about energy, the environment, public health, cybersecurity, these are all issues with big technical components. And then before I came to S&T, I actually spent a year and a half at the Department of Energy in the Solar Energy Technologies Office, and I was a Science and Technology Policy Fellow. And this is actually a picture when we got a tour of the roof of the Department of Energy building. We got to see all the solar panels that are up there. And so I do public interest technology research. And so what that kind of practically means is that I go around looking at the real world and trying to find problems. And then when I find those problems, I go and I talk to the people involved to try and understand that more deeply and think through how my research skills can be applied. So this is stakeholder-driven, problem-oriented research. And the whole idea with public interest technology is that we really need to bridge the divides across disciplines. So it's not just about thinking about things from a technical perspective, but what's the ethical perspective, the economic perspective, the policy perspective, thinking about it from all these different perspectives, and also bridging the gap between academic and lived experience. And so being able to really engage with the real world and think about how can we design technologies that actually benefit the public interest and avoid unintended consequences. And so I tend to really focus on complex systems and really dig into the human component of those complex systems. And the main way that I'd go about this is using tools from decision science. And so I kind of break that up into three main types of research. So I look at how should people make decisions, and so I do normative analysis to try and figure that out. I look at how do people make decisions, and so that involves doing descriptive research and interviewing people, doing observations to try and figure out how people are actually making decisions. And then how can we help people make better decisions? So that involves developing prescriptive interventions, but then also running experiments to try and figure out what is the impact of this intervention? Is it doing what I actually think it should? And so I want to kind of talk through how we got into this kidney transplant research. Because a lot of times when you hear about people's research, it sounds like this perfectly linear path. But this was not something that I purposefully sought out. When I originally came to S&T, I had big plans. I was going to really focus my research in the energy sector. That's where a lot of my experience was, a lot of my interest was. But I just kind of stumbled towards kidney transplant, and that's how I got here today. And so back in 2019, I was looking at different funding opportunities. I ended up making some cold calls to folks in the transplant space. And so a colleague and I ended up having a meeting with some people from St. Louis University at the Transplant Center. And we learned that there's a lot of data in transplant, and they're really interested in finding these patterns. And we were like, oh, well, hey, at S&T, we have a lot of skills related to artificial intelligence. And that's really useful for finding patterns in data. And so we realized, oh, this might be a really good partnership. And this just kind of grown from there. And so that's the project that I'm going to be really talking about today. So to start at the beginning, the whole point of kidney transplantation is to help people with kidney failure. And so once you you have a kidney that doesn't work anymore, you basically have two options. You can pursue dialysis, where you have a machine that is essentially functioning as your kidney. You often have to get these treatments multiple times a week, so it can be really disruptive. Or the other treatment that's available is transplantation, where you get a new functioning kidney, either from a living donor or a deceased donor, and you get that surgically added to your body. And we're hoping, in the future that there might be even more options. Like people are talking about using animal kidneys for xenotransplantation, using lab-grown kidneys. There's a lot of innovation happening in this space. Actually, one of the craziest things that I have learned through this whole process, which didn't really occur to me in the beginning, was that when you get a transplant, they never remove your old kidneys. They just keep adding in new ones. That was like mind-blowing when I learned that. And so in general, when looking at these two options, transplantation is the preferred treatment because it generally leads to a better quality of life. As I mentioned, dialysis can be really disruptive, and so it's often considered more of a short-term solution while you're waiting to get a transplant. And so when you're pursuing transplantation, there's a lot of steps involved. There's a lot of people involved. This is a really, really complex system. So just to kind of give you a sense of it, I'm not going to go through this whole thing, but if we kind of think starting over here at the beginning as a patient, you need to find a transplant center, find a transplant surgeon. You're probably already working with a nephrologist, a kidney doctor. And then so you have to get onto the waiting list. There's a whole process involved in that. At the same time, there are organ procurement organizations, and those are the organizations that are responsible for working with the donor families and identifying organs that are available for donation to be transplanted. And so they're working with donor families and identifying kidneys that could potentially be transplanted. They're making contact with all of these different transplant centers based on the waiting list, kind of going in order, and trying to figure out, okay, well, who can take this kidney? So as you can see, this is a very complicated process, and that we're barely kind of scratching the surface of it. And so the other challenge here is that it's constantly changing. So it's already complicated, then it's also changing. The policies and processes are constantly changing. And so that makes it really difficult to identify solutions to the challenges in this space. And one of the really big challenges that people talk about is that the demand for kidney transplants far exceeds the supply. So one of the things that probably pops out at you first on this graph is that the bars for kidneys are much higher than the other bars. So kidneys are the most transplanted organ. That's actually a big part of why we're focusing on kidneys. That's where there's the most data, there's the most opportunity for improvement. And so just to kind of drive that home, there's almost 90,000 candidates on the waiting list for a kidney transplant. And if we look at data from 2023, about 27,000 candidates received a kidney transplant. So there's a huge gap between the people who need a transplant and the people who are actually able to get one in a year. So that means that people spend years waiting on the wait list in order to get a transplant. And those people, their health is deteriorating over time. And so that's why there's so much activity and so much innovation happening to try and figure out how can we increase the available kidneys for transplant. And so to make this even harder, another challenge is that some of those donated kidneys are considered hard to place. So essentially, not every kidney that gets donated is everyone's first choice for a kidney. Sometimes there's issues with the quality of the organ. Sometimes it's really hard to find a suitable candidate in time for a particular organ. And so that's what makes a kidney hard to place. And so this problem has actually gotten worse in recent years. So if you look at this chart, you can see that in the last few years that this percentage has been ramping up. And so we're approaching about 30% of donated kidneys don't actually get transplanted. And so this represents thousands of kidneys that could be helping those people on the waiting list, but there's a bunch of challenges in getting them to that place. And so I want to kind of walk through this. So the idea is that we think that some of those kidneys that don't get transplanted there's absolutely nothing we can do. They just are not good kidneys for transplantation. Like maybe in a surgical process, there was some injury that happened to the kidney, something went wrong. So nothing we do is gonna change that. But some of these are definitely missed opportunities. And so this is a big argument for why people see opportunity. So what we see here is on the x-axis is the Kidney Donor Profile Index, the KDPI. And that's basically a measure for essentially like how much risk is associated with a kidney. So a higher number means that there's higher risk kidneys, and a lower number means that it's a lower risk kidney. And so we can see that as the KDPI increases, we look at this blue line, non-use increases, which makes sense because these higher risk kidneys are these less desirable kidneys. And often what happens is the people at the top of the waiting list are more medically fragile, and so these are actually not good options for those people. But when we look at this green line at graft survival, it's actually pretty flat. So that suggests that there are people who would really benefit from these high KDPI, higher risk kidneys. People who are lower down on the waiting list who could potentially get off dialysis for a few years, really improve their quality of life. And so that's the big challenge, is trying to figure out, okay, for a hard to place kidney, how do we find the right person fast enough in order to make that transplant happen? And so this is something a lot of people have been thinking about and trying to figure out, like, what is that alternative strategy for hard to place kidneys? So the standard process is that there's the waiting list, and so offers are made in order on the waiting list. You kind of go essentially one by one until you find someone who's like, yes, I'm definitely going to transplant that kidney into my candidate. But especially for hard to place kidneys, there's a lot of concerns about how much time that takes, how efficient that is. It creates like a huge workload where people are having to review offers that like they're definitely not going to want. And so people have been trying to figure out, okay, well, what would a different process look like? And this is still an open question. So one thing that has been tried is an accelerated process where maybe you go through the first 8 or so people and you start to realize, hey, this is a hard to place kidney. I don't think this normal standard process is going to work very well. And so you actually jump to a candidate that you think is very, very likely to accept this kidney. Because part of the challenge here is that it's finding a candidate that's suitable, but also finding a surgeon who is willing to transplant this higher risk organ. So there's a lot of different factors that go into this decision. But here there's a lot of concerns about fairness. And what about all these people who didn't even get the opportunity to review this offer? What if one of them had wanted it and you just didn't realize that? So this process is not being used right now, but I think this really emphasizes how complicated it is, how hard it is to figure out what's the right thing to do in this situation. So as we started to jump into this area, we had a lot to learn. Like I've kind of given you like a quick course in some of these big issues, but we had a lot to learn. And so we decided, okay, we need to narrow this down a little bit. So we focused on 3 main stakeholder groups. We focused on transplant centers. Just to remind you, those are the people who do the transplant surgery. We looked at organ procurement organizations, or OPOs. They're the ones who place the donor kidneys with the transplant centers. And we looked at recipients, and so they're the ones who need a kidney transplant. And so we did a lot of stakeholder engagement in the very beginning of this project. So we started off doing interviews to figure out, okay, what's the workflow? What are all the different steps that all these different stakeholders have to go through in order to make this process happen? Because what we were trying to figure out is where could AI possibly fit into this process and provide value? Then we had a workshop where we worked together to brainstorm requirements for a future AI tool. Then we brought a prototype, a mock AI, to another workshop to get some feedback on it. Then we also conducted some interviews to get more feedback on it. And then we had a third workshop where we started looking at what are those interfaces? How is the human, the user, going to actually interact with this tool? What should that look like? And so from all this different information, we pulled this all together and we realized, okay, maybe the most valuable way to add an AI tool into this process is to target places where there's tension between stakeholders. And so we really kind of narrowed in on this step involving evaluating the kidney offer. And what we realized as we were talking to people is that the OPOs, the organ procurement organizations, they really want transplant centers to evaluate kidneys faster. Like that, especially these hard to place kidneys. Like they need people to make decisions faster and they need to make firmer decisions about, yeah, I'm definitely not going to transplant this kidney, I definitely am going to transplant this kidney, versus a maybe. On the other hand, the transplant centers, they don't want to miss out on a successful transplant for their patient. And so they kind of want to keep their options open and really think through this carefully and be able to take some more time in this process. And so there's a lot of tension there because these different organizations have very different incentives, very different goals for what they're trying to achieve. So maybe there's going to be some value here in providing some decision support, an AI tool at this step. And so in order to do this effectively, we need to have interdisciplinary research. It's not enough to just get a bunch of engineers together and develop a deep learning model. That's only going to get us so far. We also need to think through what are the fairness preferences, what are the implications for fairness for this tool. We need to think through what's this human-AI collaboration going to actually look like and what tools and resources need to be in place to make this effective. And then we need to put all of that together and we need to actually generate evidence, kind of prove, is this actually a helpful tool or not, so that that can guide adoption decisions. So I'm going to talk a little bit more about each of these different pieces. And so before I jump into that, I want to take a moment to emphasize that this is a really big interdisciplinary project. I'm so proud to lead this team. We've got folks from psychology, computer science, economics, medicine, surgery, ethics, behavioral science. We have a really wide range of expertise. We have amazing students who are working on this project who are in this room, really great. We also have an awesome advisory board that's really helping us that includes transplant centers, organ procurement organizations, and a patient advocate. And so this work really depends on a huge number of people. And so I really want to emphasize that before I jump into talking about all the work. So let's start off with the deep learning model. So far I've been just like carelessly mentioning AI, AI, AI. And nowadays when you hear about AI, you probably are thinking about things like ChatGPT and more of these generative AI tools. And so what we actually have developed as part of this project is a deep learning model. So if we think of AI, artificial intelligence, as this big umbrella term, sort of more narrow than that, people talk about machine learning, and what we're really focused on is deep learning. And so for deep learning, we're going to require a lot of data, and the whole idea is that we want to be able to identify patterns. And so a big part of how this works is using this technique called artificial neural networks. And I'm not going to go into all the details, but essentially, you have all these nodes and connections between these nodes, and it's able to identify patterns without any input from a human. So it kind of automates a lot of this pattern identification process. And so that's really useful for building models. And so we've developed several models, and I'm just going to highlight two of them. So we have one model that's really thinking about this hard-to-place question. And so it predicts the likelihood of transplantation for a deceased donor organ. And so that basically is just a % score. So for a specific deceased donor organ, and this is specifically kidneys, we can say, OK, we think that there's going to be a 74% likelihood of transplantation, that type of thing. And we think that this is going to be really useful for OPOs thinking about this decision of whether a kidney is hard to place and how to approach that allocation process. Then we also have a model that's looking at final acceptance and sort of basically who makes that primary offer or takes that primary offer on a kidney. And so that is looking at the likelihood of final acceptance, that likelihood of transplant for a specific candidate rather than in general, which is what the first model's doing. So on the OPO side, that's going to be really helpful for thinking about open offers, thinking about, OK, it's an emergency. I need someone to transplant this kidney. Who can I find as quickly as possible? And then for the transplant center, we anticipate this is going to be useful for having a second opinion, thinking about automated filters. And one of the sort of specific scenarios that people talk about is a lot of times surgeons will get a call at like 2 in the morning, be like, hey, here's a potential offer, what do you think? And so they're making these like really important decisions really late at night. And so maybe AI can kind of help think through this when you're like still waking up. And so just to give you a little bit more detail about one of the models, so kind of the state-of-the-art comparison to be making here is with KDPI. So that's that Kidney Donor Profile Index that I showed before. And so that's made of about 8 to 10 attributes depending on the year of the calculation. And so our model uses all of those same attributes and more. So we're using 11 to 17 attributes depending on the timing of when you employ the model. And essentially, that as time goes on, there's more and more data available about the kidney, and so you can continue to add that data and get a more refined estimate over time. And so this includes things like health history, like the cause of death, if there's any comorbidities, things about the clinical data, so about how the kidney is functioning, and demographics. And so our model, our initial prototype model, is trained on data from 2016 to 2023 and is 93% accuracy. And so if you're curious about this, if you go to this QR code, you can actually test out our model. You can figure out if maybe you would be hard to place. And since we have developed this initial model, we had 2 PhD graduates who have actually spun off a company called Valiant AI, and they're continuing to develop these models and commercialize them. And so now we have these amazing AI models. What could possibly go wrong? Well, one challenge that we haven't really talked about that much is the racial bias that's built into the transplant system. And so, for example, black people are much more likely to develop kidney failure, but less likely to receive transplants. And this is for a lot of different reasons. You can kind of see in this chart right here, so this is a slightly older data. It's going up to 2019, but a lot of these patterns are kind of holding. And this is looking at the percent transplanted preemptively. So that means people who got a transplant before going on dialysis. And we can see that there's this huge discrepancy between white people and people of other races, where white people are much more likely to get transplanted preemptively. And so there's a lot of different reasons for this, and I unfortunately don't have time to go into all of them. And so one that I really wanted to highlight was the way that race has been historically used to evaluate kidney function and make decisions. And so, for example, the KDPI, that Kidney Donor Profile Index, for a long time included race. And basically, if you were black, that was kind of reduced your score, it reduced your score in the sense that you got a worse score, which is a higher number. It's a little bit confusing. Until 2024. So there was a huge amount of advocacy, a huge amount of debate around this. And a big part of what the challenge here is that there is a gene that black people are more likely to have that does influence kidney function, but race was essentially being used as a proxy for that. And so that's a big part of why it was ultimately removed. But as you can imagine, that doesn't mean that there's no racial bias in the data that we are training our model on. Because as I mentioned, that prototype model, that only uses data up to 2023. So that was before some of these changes happened. And so we're just starting to see what are some of the impacts of changing the way some of these calculations work. And so we know that existing biases are going to be perpetuated in AI models. And so there's 2 different ways that we are thinking about this. So one is thinking about the training data and how the model is developed. And so looking at our model, we have observed biases related to demographics, diabetes, hypertension. And so we have a whole arm of research thinking about how can we use fairness metrics to adjust our AI outputs and account for the fact that we know that this is in the training data. Then another way of thinking about it is in that human-AI interaction piece. So we know that people systematically over or under-rely on AI for decision-making depending on the context. We also know that when people know that humans discriminate in a particular situation, they tend to prefer AI. And so that's concerning because there's this perception that AI doesn't discriminate, but there's a lot of reasons to think that a lot of bias is still baked in there. And so we're doing a lot of thinking about how can explainability help. So I'm going to dig more into each of these. So when we think about ways to improve fairness, there's a lot of research on this in computer science. And folks have figured out that we can make little tweaks to the output of an AI model to improve fairness. But the problem is that we can only choose one definition. And as you can see from this chart, there's a lot of different definitions to choose from. And in a really complicated system like transplant, where there's a lot of stakeholders thinking about this from a lot of different perspectives, it's very unlikely that everyone is going to agree on the same definition of fairness. Unfortunately, it's not mathematically possible to meet all of the definitions for fairness at the same time. So just to kind of give you an example, one definition is equal opportunity, and that's really focused on fairness and access. So if we think about like the justice system, an example might be equal access to legal representation. In the transplant case, that's equal access to a transplant while you're on the waiting list. Contrast, if we think about a definition like statistical parity, that's really focused on having fairness in the outcomes. So in the justice system, that might be having the same conviction rates regardless of race. In the transplant space, an equal likelihood of receiving a transplant in time, equal health outcomes regardless of race. But the big challenge here is that if you try to meet every definition of fairness, you end up having too many constraints, and you can't actually solve everything at once. So like one comparison that people will often make is this distinction between equality and equity. And sort of this notion of like having the same process, having the same access for everyone isn't necessarily going to achieve the same outcomes for everyone. That maybe we need to have different processes in order to get the same outcome for everyone. And so that's the big challenge here. And so as we are moving forward in this project, one element that we're trying to advance is, okay, well, first off, how do we even figure out what people's fairness preferences are? And so what we have figured out is that we can use disagreement feedback, because it's really hard to go up to someone and say, okay, well, what definition of fairness would you prefer? Like, people don't really think that way. But we can show them, here's a bunch of here's a situation that happened. This number 6 candidate received the transplant. Do you think this was fair? Tell me on a scale from completely unfair to completely fair. And if we show people a bunch of cases and we look at sort of the pattern and how they're making judgments about fairness, we can actually derive what fairness definition they're using. And so that's something that we're working on, and we haven't done it yet, but our next step is to actually go to the transplant stakeholders and collect this information and find out, okay, we are pretty sure there's going to be disagreement, but how much disagreement is there? So that's an open question that we're pursuing. And then once we find out what people's actual fairness preferences are, we're trying to figure out, okay, well, how can we kind of cleverly combine some of those fairness preferences, knowing that it's not mathematically possible to satisfy all of them. And so one strategy that we're pursuing is thinking through, okay, well, what if we identify a bunch of AI models that all have a similar performance but vary in terms of their performance? So here we can think through, okay, well, maybe model 1 and model 2 have really similar performance, similar definitions of fairness, but model 3 has a very similar level of performance, a slight difference, but it has a different definition of fairness. Well, so then if we're thinking like, okay, well, the pluses are transplant decisions, the negatives are no transplant decisions, well, we might be worried about this individual, that this is someone who the first 2 models say no transplant, but this third model says yes transplant. So it says that it should be a plus. And so the notion here is that, okay, well, if this type of decision is going to depend on which model is chosen, that's not very fair. So what we can do is we can kind of pull all these models together and let individuals receive the best possible outcome from all fair models, so that no one is disadvantaged by the model choice. So that's one way that we're thinking about advancing fairness in these models. And so this next piece, another way of thinking about how to deal with bias is this human-AI collaboration piece. And so in this context, in the transplant context, we're working with experts. So they know a lot about the domain. But the challenging piece is trying to figure out how do we integrate knowledge about the AI model with that domain knowledge. And so that integration has to happen in order to have successful human-AI collaboration. And so we've been doing lots and lots of experiments in this space. And of course, we can't run to the transplant community every time we want to run an experiment. And so we've been looking at a bunch of different analogy domains. And so first, I'm going to talk about a series of experiments that we ran looking at real estate decisions, where we asked people to pretend to be a real estate agent and do a matching task between buyers and houses. And so what we found is that people use relevant AI limitations to assess AI capability. And so in thinking about this explainability question, one thing we were testing out was, okay, well, what if we tell people about limitations of a model? And so these are some examples of model cards where we tell people, okay, this model is 83% accurate, but it has some limitations. And we vary the limitations to see how does the limitation affect the way people interact with it. And so just to kind of give you one example, so for this limitation that's focused on income, we gave them a bunch of different cases, and some of those cases were in scope. And so here the limitation is the AI is not trained on buyers with household income less than 50K. So that means an in-scope case would be when the income is greater than 50K. That type of case would be in the training data for the model. Versus an out-of-scope case would be when the income is less than 50K, when we've met that limitation. And so we did a bunch of different experiments, and this is aggregated data across all those experiments. And we looked at multiple different limitations related. Some were related to income, some related to age, and some related to race. And we found this really interesting pattern that we're continuing to dig into. So for the in-scope cases, where the income's greater than 50K, there's no limitation to be worried about. Generally, people perceived the AI to be capable. That's why we see positive numbers for these blue or gray bars. But when it was an out-of-scope case, when it was the income was less than 50K and the model was not trained on these types of examples, then people started to perceive a negative capability. But that really depended what the limitation was. So when the limitation was related to income, there was this sense that, okay, that's really related to how you would match buyers and houses. That's going to really matter. So if it's not very good at that, that's going to really make it less capable. Then for age, there was a little bit of a weaker relationship there. We're like, okay, well, you know, age could kind of be related to income, but not perfectly correlated. So it's not going to matter as much. It's going to be less capable, but it's not as extreme as for income. And then for race, there was this perception that that doesn't matter that much for this task. And so it had very little impact on the perceived capability of the AI. And so when we think about how we're going to apply this idea to the transplant case, this is kind of exciting because it means that we can rely on experts to use their domain knowledge to navigate these types of limitations of an AI. So as long as we make sure that they understand the limitations, like people are capable of navigating that and figuring out, oh, okay, this limitation matters more in this case. They're able to figure that out. And so as we move forward in this project, that gives us a lot of confidence that people are going to be able to understand this. Another example of an experiment that we did, we found that the value of AI depended on the context. And so in this experiment, it was about basketball betting. And so here it's a risky context, and people are really incentivized to bet. We actually told them that we're going to pay you more money if you are more successful in this betting task. So people were really motivated. And basically what we found was that in this context, people didn't need encouragement to bet. They were very excited to bet on these basketball games. What they needed was encouragement to not bet, to pass on a game. And so just to kind of walk you through how this worked, so for each case, we showed people some basketball stats so they would have something to base their judgment on. We told them the AI is calculating. And then they got an AI recommendation. So here, the AI said pass. And so you can see this person being very skeptical. Like they don't want to miss out on an opportunity to make some money. But like maybe it's not a good idea to bet in this case. And here, in this situation, the AI was correct. The crocodiles lost. And so that meant that it was a good idea that they had followed the AI. And so in this experiment, what we found was that people were able to tell the difference between a low reliable and a high reliable AI. And because they could tell that difference, the reason that they performed better in the high reliable AI condition was because they were more likely to listen to the AI when it said to not bet. Like that was where all of the value came from. And so when we think about this in the transplant context, that really tells us that AI is going to have very case-specific value. It's not going to be equally useful in every single case. And so we really need to think through how can we target the cases where it's actually going to have some kind of marginal benefit. And so as we kind of move into these AI adoption questions and like, what is this implementation going to actually look like? This is something we talked a lot about in that initial stakeholder engagement. So when we talked to organ procurement organizations, they were really excited about the idea of having a tool that would help them screen for a hard-to-place kidney. And so that raises a lot of questions about, okay, well, how much is AI going to help in making these types of judgments about whether a kidney is hard to place? When we talked to transplant centers, they really framed the AI as an opportunity to get a second opinion. That's what really excited them, thinking about this decision of whether or not to accept or deny a particular kidney offer. And so that has raised some questions for us about how much does the timing matter? Is it okay to show the AI score right away when a surgeon is making an evaluation about a kidney offer? Or do they need a second to look at the kidney offer and then maybe after they've made their own judgment, then they can consult a second opinion as sort of a later step? And so we are going to try and find out the answers to these questions. And so we are in 2026, next year, going to be running a field trial of our AI tool. So one of our partners is UNOS, the United Network for Organ Sharing. And they have developed SimuNet, which is a behavioral science platform. And it looks exactly like the real organ offer system, which is called DonorNet. And so the idea is that we're going to be able to run an experiment. We're going to do a randomized control trial. So we're going to randomly assign people to essentially receive the AI, not receive the AI. And we're going to be able to see, like, okay, well, how much does it help? Like, do we see any task performance improvements in accuracy? And do we see any improvements in efficiency? So even if we don't see people making better decisions, maybe they're able to make those decisions faster, more easily, and that's the benefit of an AI tool. And so we're very, very excited about the opportunity to actually test out and generate some real behavioral evidence on how are people going to interact with this tool and what's the actual impact going to be. And so, I see a lot of potential for AI in this space, but I also see a lot of risks. And so another aspect of this project has been kind of thinking through what is AI adoption and implementation going to actually look like? And so we did a series of interviews with organ procurement organization leadership to try and get a sense of, what are going to be the big pain spots in this process. And so I'm going to just highlight two of the things that came up there. And so one of the things that came up was related to misconceptions. So I'll read this quote. The transplant system is loaded with bias. Ideally, the algorithms will not be loaded up with so much of that bias. And so there's really an expectation here that that AI is going to help solve some of these challenges related to bias. And that's a lot to live up to. And so we need to be thinking really carefully about, how much can we actually do in our AI model, and how do we communicate to people what we are and are not able to achieve. Because I think it's really important to not just let this lie. We need to directly address these types of perceptions. And then there's also a lot of disagreement about how this adoption rollout should happen in the first place. So for example, on this side, since we don't know whether AI is going to prove successful, we're going to go for it. We're going to be competitive. We're going to stay on the cutting edge of all technology. Versus this other perspective, we would be pleased to put this into place as long as the entire country, that all the OPOs are doing it. And so there's this really clear, basically market versus regulatory tension happening. And so even though OPOs kind of have separate territory, there is a lot of competition between them. And they are evaluated relative to each other. And there's a lot of pressure on them to perform relative to each other. And so that type of kind of market mechanism, that competition, is really pushing for innovation, pushing for integrating tools like AI to try and be competitive. But there's also these concerns about fairness. And so if some OPOs implement AI and others don't implement AI, what does that look like for the system in general? Maybe that's not fair. Maybe all the OPOs need to be implementing AI at the same time. And so these are big philosophical questions that need to be addressed before we can move forward with a lot of AI adoption in this industry. And so kind of my answer to this is that the best way that we can meet the needs of these different groups of people and these different perspectives is that we need to generate evidence. That we can't just say oh, AI is probably going to be really important, really valuable in this process. We need to be able to point to evidence, like from a randomized control trial, to really prove what some of those potential benefits are. And so I hope I've convinced you that there are a lot of really important problems to solve in transplantation, and that AI is part of that solution. It's a really promising strategy to pursue. And there's a lot of reasons for where we think, or ways that we think AI is going to be valuable, but it's also going to be really hard. This is not going to be an easy process to effectively integrate AI. And so I'm very excited to be working with this team of a lot of very passionate people to kind of think through a lot of these challenges. And so one thing that we talk about a lot in systems engineering is that all models are wrong, but some are useful. And that definitely applies here. For example, we know that the world is not a perfect sphere, but most globes are perfect spheres. And it's not to say that globes aren't useful. They're very useful. But we need to understand the limitations of our models. And so I would argue that AI developers are really responsible for anticipating the consequences of their technology. And so some of the important things to do include things like integrating stakeholder input. The easiest way to do this is to have stakeholders on your team and to be directly talking to people with that lived experience, because those people are really, really good at anticipating consequences and what this is going to look like in the real world. It's also really important to evaluate any bias in your AI outputs and constantly be on the lookout, constantly be critical for any bias that's showing up in AI models. And then it's really important to conduct field trials and actually look at that human-AI interaction piece and not just assume, oh, this model's 93% accurate. That's probably what's going to happen in real life. In real life, you're going to have some complicated interactions with the expert who's interacting with the tool, and we need to understand what that's going to look like. And so if you are interested in this space, if this sounds really exciting to you, one thing I want to encourage you to do is support the donation system. And so register as an organ, eye, and tissue donor. So you can use this QR code to go to donatelife.net. If you registered as an organ donor on your driver's license, if you have a little heart on your driver's license, that covers the organ donation, but it actually does not cover eye and tissue donation. So going here will let your loved ones know that you would also like to be an eye and tissue donor. Because some of the tissues that you can donate include things like heart valves, bone and associated tissue, skin, veins and arteries, nerves. All of those are things that can really, really benefit people who are going through different health conditions. Also, if you're interested in this project and you'd like some more information, we do have a website, so you can check out our website. And that's a really great way to kind of stay connected and up to date on what we're doing. And so with that, I'm happy to answer any questions.
So if you have questions, just raise your hand. We can run a mic to you. While we're waiting, I have many questions. I'll distill it down to just a few. So are you working, or do you anticipate working on other tissues? Or are you mainly focusing on the kidney for now?
Yeah, so this is something we've talked about, is like, to what extent can we apply the work that we have done to other organs? And I actually think it's going to be tricky to just take exactly what we've done and apply it to other organs. I think we would essentially have to start the process over because some of the issues that you have with kidneys are not necessarily the same for other organs. So a lot of what happens with other organs is they're actually really prioritized in the placement process. And so they're going to spend a lot more time finding a home for like the heart and the lungs first. And then as soon as they find those homes, then they can start really thinking through the kidney. Because unlike some of those other organs, you actually have more time on the kidney. Because I didn't really go into all the details, but once a kidney has been removed from the donor's body, they actually have a pump that they can put it on. And it can stay on that pump for about 24 hours, theoretically. And so that's kind of what gives you a little bit of wiggle room for kidneys, but it's also how you end up in a situation where you have these hard-to-place kidneys and you don't actually succeed in finding a home for them because you were really focused on making sure that those hearts and those lungs went where they needed to get, because those are much more fragile organs.
I learned about the pump because I filled out I was checking my numbers and I was like, oh, that's interesting, and I figured that out. So can you tell us the scale of this study? How many instances or organs do you will be assessed to when you do this clinical trial?
Oh,
and
yes.
Is it at the organ level, or is it on the recipient level?
Yeah, so we're still kind of in the design phase and sort of finalizing what that experiment is going to look like. But right now, what we're kind of thinking is that we're going to basically show people between 6 and 9 cases and see how they respond to them. So there's a lot of different ways that you can approach that. And so we're basically expecting that people will either kind of sit down and do all the cases right away, or they might leave and come back and leave and come back. But we're going to kind of leave it up to the participants.
Great.
But yeah.
Do that in person.
So, Dr. Canfield, I wanted to ask you, how important is the role of transportation in the entire process? So is that a sector that is quite big enough, or is it a problem that has already been handled by the OPOs? I believe
there's open questions related to the transportation. That's definitely something that people are working on. We didn't focus on that too much during this project, but there's some other work that some members of the team have done that have been looking at how can we use simulation to better understand some of those transportation constraints and how those logistics work. Because just again, to give you an example of one of the challenges that happens is maybe they have identified a recipient for a particular kidney, and the kidney is literally en route to that person, and then something changes with the candidate. that some lab results come back and they realize, oh wait, they can't do a transplant right now, like something's not perfect. And so all of a sudden this kidney is en route, and now it needs A, to find a new destination, and then B, get to that new destination. And so trying to figure out how do you handle that kind of like real-time reallocation during the transportation process is one example of the things that people are trying to figure out.
Hi, we have a few questions from online.
Yeah.
One of them is they understand that AI takes a really long time to be adopted into medicine and healthcare, and randomized control trials take a significant amount of time. Do you have suggestions to make this faster to adopt such rapidly changing technology with AI?
Yeah, so I mean, I think there's some tension there in terms of, we don't necessarily want to adopt things too quickly. I think it is really, really important to take the time to do that evaluation phase, and that you don't want to skip that. And so there might be strategies in terms of thinking about how you can potentially do randomized control trials with tools that don't fully exist yet. That might be one strategy, that you kind of have a notion of what the AI output is going to look like, and so you can start running experiments in advance. And so that's kind of what we were trying to do with our analogy domains, that we were like, okay, well, we can't wait until the end when we have this full deep learning model to start doing our human subjects research. We need to start that sooner. And so trying to figure out about how you can be clever about that.
We have a few more online. What are the ML algorithm techniques that you've used in this project?
Oh, this is testing me. Yeah, that is not my area of specialization. I don't know if maybe I can get somebody in the back to help me out there. Akin Kumir, Alisei, do you have anything to answer there?
Yeah, I think it's a fit for deep learning neural network model.
Awesome. Thank you.
Any other questions? So Dr. Canfield, we really want to thank you for the great work that you're doing and for sharing in a way that's very accessible and understandable. And with this is our token of appreciation for being part of the Discovery Series. Thank you very much.
Thank you so much. Yeah, I'm really glad I got the opportunity to talk about this.
So please join us next month, and thank you for your attendance today.